Okay, so here we are in the lab again, and today we are going to solder some more, and we got to do our front end, get our front end on there, get the decoder chip so we can decode the addresses, and we'll do the buffers and some bypass caps, and that should, oh, and then our jumpers, our address select jumpers. And so once we get that done, then the next video will be on getting into some code and writing some little chunks of code and initializing our board and checking out the signals on the scope and see what we got. Um, but today we're going to do the front end soldering and chip installation. All right, so we got the board over here. Got it under the microscope. Clean it up a little bit. That flux loves to collect dust, and the boards just in general kind of collect dust. So just clean that up a little bit, and then we'll get the part on there. All right, I bought 2 chips just in case we blow one up. Never know. Things like that happen, and you just don't run down to the store and buy one of those, especially with such a specific package. So it comes from Mauser and DigiKey. It comes like that. It's on a tape roll, and they just cut them however many pieces you want. So you got to peel this plastic off the top. It gets kind of tricky with the scissors, or I mean the tweezers. And dump it out, and then they always land upside down. So then you got to flip them back over, and sometimes some parts it's a little bit tricky to do that. They're so small. You don't want to bend the leads. That's the last thing you want to do. So see, now notice the dot on the board signifies pin 1. Well, you got to get the dot on the chip in the right pin there, or else it will blow the chip. If you put it on backwards and power it up, most likely it will blow the chip. It'll probably start smoking and pop. Especially MainBrain can put out 3 amps, so it's just like a little bitty diode in the wrong direction across there, and it'll pop it. So make sure the orientation of the chip, that's the most important thing. All right, so I add a little bit of flux, just a little bit. Sometimes you don't have to right at first, but you got to get it kind of lined up, get all the pins lined up. And I've already had a couple cups of coffee, so it's a little more challenging even. But yeah, you got to try to get the one pin stake down, and it looks like this chip kind of like the legs sit up or something a little bit. I'm having a hard time getting it to stick down. See, I'm kind of moving off. Try to keep it on there for you guys to see it. Try to get it on there. So you just want to get that one pin attached, and then see, and that's pretty good on alignment already. You're allowed, IPC allows you to get half the width of the pin off the pad. So you're allowed 50% over, and that looks like crap when it's that far. There's no problem with the microscope. You should have your parts pretty straight. I mean, some of the chip caps ain't a big deal, but I mean, the ICs, you want your chips to be straight. You want people to look at it and think that it's good. You don't want them to say, wow, that chip is really crooked. Oh yeah, see, now I didn't get that one leg staked down, so it popped off. So we get to start over. Sometimes it can be a little tricky. Looks like the one stuck a little bit. And it looks like, for some reason on this chip, it looks like the legs are sticking up. Maybe I should have cleaned some of the PCB people's tin off of there or something. Maybe it has a bump, something. But anyway, it's kind of giving me a little bit of a fight. But if I can just get it stuck on there. There we go. That should do it. All right, so now it's stuck on there. It's lined up. So now we can tack it down permanently. So the first thing you want to do, I like to add flux. Some people don't like flux, and some people say you can't have too much flux, but I disagree with both. You got to have flux for good shiny solder and good flow, and you don't want to overfill it because then it sucks out a lot of heat from your soldering iron. So just like we did with the connector, you do one pin at a time, but you got to make sure. See, I think those pins are kind of like sticking up a little bit on this one for some reason. I don't know. But yeah, just one pin at a time. Make sure that the solder flows to both the pin and the pad. So we're going to add a little more flux here. This is what it looks like outside on normal vision. Just one pin at a time. You got to keep your tip clean. Don't let any of that black stuff from the burnt flux stay on there. Clean it. Even if it's every single pin, you have to clean it. You got to just keep it clean, because if you put a little ball of solder on the tip, it will hold it on there, and then when you touch the pin, it will suck off some of that solder, usually just about what it needs. But you have to be careful, and if you touch two pins at the same time, you can get a blob across two pins, and then you'll have to either work it off or get the solder wick out and take it off. But yeah, just keep going on one pin at a time, and don't leave a pin until you know it's soldered good to the pin and the pad both. You want to keep wiping your tip. Keep that tip shiny clean. That'll give you good transfer of heat and a good flow of solder too. All right, so now we're on the other side. Halfway there. One pin at a time. Make sure they're a good flow from the pad to the pin. See how when you add solder to the tip, see I just wiped it? But when you add solder to the tip, I'm adding a little bit of flux there. That's a little too much. So you'll see, not only does it splatter more when you put the heat to it, but it takes a lot of heat to get to the solder to flow, and it also creates more burnt flux on your tip too. But once it gets going, it's good. That flux helps a lot. But see how you put a little dab of solder on your tip, and if it's clean, it'll just go right on there. And just put a little dab of solder there, and then the pins will drink it. They'll drink what they need. Just like that. Make sure they're all nice and smooth and shiny and flowed together. And there you go. Just like that. Now we clean it, dip the Q-tip in alcohol and get a lot of alcohol on there to flush that flux out of there. See how the Q-tip's turning yellow, sucking up all that flux? Yeah. Yeah, that's starting to look pretty good. Oh, there we go. We still have to solder on the cap, so there's no need to get it pristine clean yet. We just want to knock off that flux so when it dries, well, before it dries, so it's easy to clean like right now. See, it's just picking that right up, cleaning right up. All right. All right. Looking pretty good. Looking good. So now, one thing you can do is you can take and use a pick and just check the pins to make sure that they're soldered on, just in case. Because you can have a loose pin, and because you're looking straight down and onto it on the microscope, so it can fool you sometimes. But it looks good. This one looks good, so I probably won't check the rest. It doesn't seem to be a problem. This one seemed like the pin stuck up a little bit. That's why I wanted to check it. But yeah, now it's time to get the bypass cap on, the little chip cap. Get that thing rolling. 24 hours later. All right, so now we got our little tape of chip caps, our tape reel tape. And you gotta peel it back. I got a little bit too much. As you peel them back one at a time, then you get a longer, like used up piece on the end. So you might want to keep them a little bit trimmed up. But anyway, and then see now, I got a little bit of flux on my tweezers, so I can't let go of the chip cap. So you want to keep your tweezers pretty clean too. Just dip them in the alcohol, wipe them on the sponge or with some paper towel or something. So I like to add a little bit of solder just to one pad. It gives you something there, so once you line it up, you can tack it right on there. I'm going to turn the board. I like to turn the board so it's like I'm at 90 degrees with it. It's easier to solder that way for me anyway. There we go. Let's get the chip cap in there with the tweezers. See, that way it lines up easier with your hands. So you just tack it on there. And then you don't want to hit the same side with the solder because it'll reflow it and it'll fall out of place. So you just want to get a little solder on that side, other side from where you started. A little bit of flux helps. That's a little too much, but it's hard to tell. They're so small. I mean, a little dab of flux and it's flooded, but that's okay. Just like that, and that's soldered. And we'll flush it with alcohol while it's still nice and warm, and it'll clean right up. Look at that. And there we go. Takes a lot of alcohol to get all that off. Then you'd want to hit it with a fresh one on the other end of the Q-tip with fresh alcohol, and that looks like it did pretty good. So there you go. There's that. So now we flip the board over and we'll do the other three chips and the kind of little jumper. All right, jumpers. All right, so we got our front end chips on the board and everything's looking pretty good. So it's next thing to do, we have to take disassemble MainBrain. It's on, we got the motion board on there. So let's get the motion board off and plug in our new IO board and check for VDD and make sure there's no shorts. And then we'll call it good for this video. And then the next video we'll jump in to debugging the signals and stuff like that and writing some code. All right, so here's MainBrain, and we'll take these 4 screws, the long screws I use for legs, and it also holds on the bottom IO card. So let's pop that bad boy off of there. put some paper towel down because I'm going to flip it over, and those the display's too expensive to scratch up, and it gets scratched up and banged up pretty good over the years because uh, as soon as I get the parts on the board, MainBrain usually runs 24/7 for it's ran for if one version or another is ran for years and years, probably 3 years total. So we want to get these screws out of here. Everything I always use stainless steel socket head metric screws. So these are 3 millimeter screws, 3 millimeter threads. Get those out of there. Then the board just comes right off. That's the I/O board, or I mean the motion board. Ah, uh, seems to work real well so far. Haven't had any trouble with it. Maybe one last revision. I don't know. Everybody, I always say one last one, but there's always another one. It seems like eventually. So the screws that hold the display on, the display I silicone it to a some FR4 material that doesn't have any copper cladding on it. So the screws are tapered head screws, and they have a little smaller Allen head wrench, hex key wrench. All right, so we get the ribbon cable put back on the MainBrain, and flip MainBrain over so we can see the screen. And then we're going to plug in our I/O card onto the other end of the ribbon cable, just like that. Get it all stretched out here. And let's get rid of these screws. All right. Get MainBrain stretched out here. Get the meter out so we can measure. Before we plug it in, we want to make sure that there's no shorts. And the first thing I want to check is if these screws are grounded to each other, which they should be connected with the ground plane. But I just wanted to make sure, just so I know, they should be. All right, and then we just want to check the cross from ground to VCC on one of them, and check see if it's shorted or not, because it wouldn't be a good thing if it was shorted. All right, everything looks pretty good. Ground is to ground, and VDD doesn't seem to be grounded, but it is kind of low right here. So I'm like, I better unplug this thing here. Check the resistance. The resistance itself, I was in diode mode, but resistance is 41 ohms. Something to think about. So let's unplug it from MainBrain and check it and see. Check it again. You got to be careful because sometimes you don't get a good connection because there's some flux residue on it. But yeah, there's no short to ground from VDD. So Plug it back in. So now, I think we can apply power here. There we go. Well, nothing smoked. Everything's good. And so now we want to check to see if we have VDD. And then we'll call it good right here. We should be good. Try to do it where you guys can see it too. All right, 3.27 volts. That's a win. Okay. I should wrap it up. See you on the next video.